Today we're going to learn how to graph in intercept form. Intercept form is this form written right here. In this form, the P and the Q are the x-intercepts. So I know it says that somewhere in these bullet points, but you may want to write out to the side that P and Q are x-intercepts. An x-intercept is where the parabola crosses the x-axis. So here in this picture, here's point P and here's Q. Notice the coordinates are P, 0 and Q, 0 because they are on the x-axis. The subtraction signs in here actually make it opposite. So see how it says minus P, but then the intercept is P. It says minus Q, but the intercept is Q. So up at the top of your page, I'm going to write an example. Leave a space here and then write x minus 2 times x plus 3. An x-intercept exists when the y value is 0. So what we're really doing is we're solving this equation. 0 equals x minus 2 times x plus 3. Okay, imagine for a minute that I have two numbers, one in each hand. I'm going to multiply those numbers together, and the answer is 0. What has to be true about one of those numbers? One of them has to be 0. The only way to multiply two things together and get an answer of 0 is if one of them is 0. So that's the strategy here. What x value would make the first set of parentheses equal 0? What number minus 2 is 0? 2. So the intercept is 2. The x-intercept is 2. What x value would make x plus 3 equal 0? Negative 3. So your x-intercepts would be 2 and negative 3. That's the math behind it, but really the shortcut is if you see minus 2, the intercept is positive 2. If you see plus 3, the intercept is negative 3. So you might want to write in here opposites. The axis of symmetry is perfectly symmetrical between those two intercepts. So there's two ways to find the axis of symmetry. You can either take your fingers and count in from the intercepts until your fingers meet, or you can find the average of the intercepts. P plus Q, add them together and then divide by 2. That'll give you the average, which will be the axis of symmetry. We are going to fill in how to find the maximum minimum value after we've done example A, because I think you'll understand it a little bit better. All right, I am going to color code as we do this. So if you are a visual color coding type of a person, this should be helpful for you. Our first step, because this is intercept form, is to identify or find your x-intercepts. You can either think of putting the parentheses equal to 0, or just think about the opposite of whatever's in the parentheses. So if it says plus 2, what is our x-intercept? Negative 2. And if it says minus 4, what is the intercept? Positive 4. So your intercepts on your x-axis are at negative 2 and positive 4. So put those 2 points on your x-axis. The next step is to find your axis of symmetry. Again, there's two ways to do this. You can put one finger on the intercept on the right and your other finger on the intercept on the left and count in 1 unit at a time until your fingers meet. Or you can add the two numbers together, negative 2 plus 4, and then divide by 2. Either way, you will get 1. The axis of symmetry is at x equals 1. Oh my gosh, I can't do a dashed line on the line. Okay. Now it might seem like we're nowhere close to done, but we're actually almost done. We already have 2 points on the parabola. Your next step is to find your vertex. Your vertex has to be on the symmetry line. The first part of your vertex comes from the axis of symmetry. So the x-coordinate of our vertex is 1. How do we find the other half of our vertex? Use the equation. Plug it in. So y equals parentheses. Oops, I should really be using green for this, shouldn't I? Details. Y equals 1 plus 2, closure parentheses, 1 minus 4, closure parentheses. Y equals 3 times negative 3, which is negative 9. So the y value of your vertex is negative 9. On your axis of symmetry, put a point at negative 9. Our vertex is at 1, negative 9. Now we have our 3 points. We can draw in our parabola. I feel like with standard form, you have to do the opposite of b plus, or the opposite of b over 2a, and then plug that number in. I feel like there's a lot of calculating that you have to do with standard form. With intercept form, I think it's kind of nice because you put your intercepts on the graph, count into the middle. That's the only thing you have to plug in, and then you're done. Okay, is our vertex a maximum or a minimum? It's a minimum because it's at the bottom. And what is the value of the minimum? Negative 9. Remember that the y value of your vertex is your max or min value. The domain is also all real numbers, just like it has been for all of our parabolas so far. And your range. If your minimum value is negative 9, all of your y values are either negative 9 or something larger than that. So y is greater than or equal to negative 9. If you can make the connection between the minimum and the range, or the maximum and the range, it'll help you to figure out what your range is. Okay, let's go back up to how to find the minimum or maximum, and let's figure out what we should write there. I'm going to say find the halfway point between the x-intercepts. And that is your axis of symmetry. Plug the axis of symmetry into x to find the corresponding y value. It might be helpful for you to also write that your vertex, the first part of your vertex is the axis of symmetry, the second part of your vertex is your maximum or minimum. Now remember me saying that word problems like we're going to do next week are actually really easy if you know how to find your vertex. That's because the vertex is the maximum or minimum. So if a kangaroo jumps, the path of the kangaroo's hop is a parabola. How high does the kangaroo get when it jumps? That would be the y value of the vertex. So if you can find the vertex, you've got all the information you need to answer that kind of a question. You might see a kangaroo question tomorrow or next week or whatever. All right, give example B a try on your own. Before you start, take a look at it. The 2 does not affect anything. Well, it does, but it's not going to affect how you do the problem. You do not distribute the 2. The only time the 2 is going to bother you is when you get to this step. when you plug in your x value, you will have a 2 in front of those parentheses. So when you plug a number in, think about that 2. But before then, just don't let the 2 bother you. Your x-intercepts are +7 and +3. Now here's a common mistake. You guys are used to finding pairs of numbers and then putting them as an ordered pair. The intercept is not the point 7, 3. You have intercepts at 7 on the x-axis and at 3 on the x-axis. The x-intercepts are 2 separate points. This one's actually pretty easy to see the axis of symmetry because there's a darkened line right between them. So both of these are 2 units away from the line x equals 5. So our axis of symmetry is x equals 5. You could also find that by adding 7 plus 3 is 10, and 10 divided by 2 is 5. So our axis of symmetry is x equals 5, which means the vertex is 5 comma something. And to figure out what that something is, we plug 5 into our function. So 2 parentheses 5 minus 7, parentheses 5 minus 3. 5 minus 7 is -2. 5 minus 3 is +2. Because the symmetry line is the same number of units away from each intercept, do you see how in both of our examples in the parentheses we had a positive and negative of the same number? That's going to happen every time. So if you get -2 in the first set of parentheses, you should get +2 in the second set of parentheses. So that's just something to keep in mind. This is where the 2 in front, finally we have to do something with it. We have to do 2 times -2 times 2, which would be -8. So the y value of our vertex is -8. Does this parabola have a maximum or a minimum? Minimum. What is the minimum value? The domain, that's easy, all real numbers. Y is greater than or equal to -8. Remember, if your parabola opens downward, say your vertex is 3, 5. That would be a maximum at 5, and your range would be y is less than or equal to 5. If it's a maximum value, all of your y values have to be 5 or smaller.